Alrighty. Hi, everyone. Thank you for joining us for all of the talks so far as part of the MLOps Salon Monitoring Edition. Now we get to the super fun, interactive, hopefully controversial panel about the future of model monitoring. My name is Manasi. I am the founder and CEO of Verta, and privileged to have a really great group of experts here who are going to be weighing in on model monitoring. So without further ado, I will ask the panel to introduce themselves. I'll just go in the order that I can see them on the screen. So Sebastian, if you wouldn't mind giving a quick background on yourself, the kind of research you do, and for those who have given talks, maybe the 30-second pitch on what your talk covers.
Thank you. So hi, everyone. I'm Sebastian Schelter. I'm an assistant professor with the University of Amsterdam. My research is focused on the intersection between data management and machine learning. So exactly all the problems that we talked about. And I also have an industry connection. So I've been a senior applied scientist at Amazon for a couple of years. I'm one of the authors of the DQ library for data validation. That's, for example, the basis for the model monitor service in AWS. And also in our research, we have a strong industry connection, and we work with many retail companies, and we have all the problems that are in the focus of this panel.
Awesome. Thank you. If we could go to Max next.
Hi, I'm Max Cantor. I'm a software engineer of machine learning at Condé Nast. I work primarily on our machine learning platform, Spire, which manages thousands of models in production for user segmentation. And I discussed, primarily from an engineering perspective, the interplay between the code base itself and data abstractions and all of that with your monitoring tools and how the code itself affects monitoring.
Thank you. Next, we have Ganesh.
Hi, I'm Ganesh Nagarathnam, Senior Director of Market Intelligence, S&P Global Market Intelligence in Machine Learning Engineering and Operations. My team builds out a generic purpose analytics platform for generating insights for our customers and using machine learning and advanced data science. Earlier part of this panel, I had a talk wherein we were discussing about the MLOps drivers and then how we go about in building our data science analytics platform. And we also presented a case study with one of our product teams. And I'm looking forward to having a fruitful discussion, controversial discussion on the model monitoring piece from the experts here. Thank you.
Awesome. Thank you. Next, we have Saeed.
Hello, everyone. My name is Saeed Shahrai. I'm lead data scientist in S&P Global Market Intelligence. I'm part of a new product development team of S&P. Our team is basically responsible to build new product, machine learning basically based solutions. And we are working closely with Ganesh. We are basically an end user of the platform that he has built. And I'm very excited to be part of this panel.
Awesome. Thanks so much. All right. Last, we have Shreya.
Hi, I'm Shreya Shankar. I'm an incoming PhD student to UC Berkeley. Most recently, I spent a couple of years doing applied machine learning as the first ML engineer at a applied ML startup that came out of Stanford. And I gave a talk on the kinds of bugs that can happen after you promote models to production and kind of why is this hard to work on.
Awesome. Thank you all for taking the time, and very excited to hear the different takes on model monitoring and what it holds for the future. So let me kick it off with maybe anecdotes that are that you can share about why model monitoring has been important in your work. The more egregious, the better, but you can take your pick. And in any order, feel free to just jump in.
Do we want to just go maybe in the same order we introduced? Or?
I have a small anecdote. I can't name names, of course, but I think something that we often forget when we think about models is that the predictions of models are not only consumed by humans that might take some actions, but also by automated systems that take actions. And then there are use cases where a wrong prediction might not be too much of a problem. Like if you recommend music or so, you can just skip to the next track. But for example, some of the work that I've been doing has been on forecasting in retail use cases. And there, it can, for example, happen that you get bad data into your forecasting system, then your forecasting system produces a forecast that is way off. And then you have automated buying systems that basically make buying decisions based on this forecast. So there are cases where wrong predictions can become extremely expensive.
That's awesome. So it's kind of a cascade where you have no checks and balances and things just keep going. That's fantastic. Thank you.
Maybe I'll start. Yeah, go for it. Go for it, Max.
Yeah. So one I think I talked about in my talk was, but I think it's a good one, is it's not even so much a bug per se, but it's doing exactly what we expected it to do, but we were asking the wrong question. So we have this like daily reporter for our models that tells us how many models were trained over like the last day, and of those, which ones succeeded and which ones failed. But one thing that we didn't account for was that the query that we were running to do that test was just looking at of the models that were launched, which ones succeed or failed. But what it didn't account for was, let's say a cluster didn't get launched for some reason, or some model didn't get picked up for some reason. We actually were missing the ones that were supposed to have gotten launched but didn't. So we eventually had to change our query to account for that. So, it's just like a little thing sometimes that you just don't think about.
Right.
Yeah.
I know others had things, so I'll just set an order on these things. Ganesh, if you want to go next.
Yeah, in my talk also, I was talking about the half-life of a model. I love physics. So when we talk about the radioactive decay, if that is in one end of the spectrum, you have the model decay like on the other end on the other side of the spectrum. And if it's not going to decay like after a million years, probably your model is going to decay in a matter of weeks. So that is why model monitoring becomes so important. And within the organizations, with big organizations, the unique challenges are: how do you address the model drift? Do you invest in a platform like that is going to solve these problems? Do you want to have a Swiss Army knife kind of a platform that could help you alleviate this? Or do you want to build your own model monitoring packages using the open source libraries? And what are the cost and impact of those predictions? And then how do you figure out which features are less important and which features which are of high importance are contributing to the deviation? So those were the areas that our team, my team, and Saeed's team, are pretty much focusing on, more in terms of the monitoring and the data quality and the model quality as well. And we have started putting our heads around explainability, and because that becomes a key factor in the financial sector.
Got it. Awesome. Thank you for that. Shreya, any comments on anecdotes? Sorry, and if someone else wants to jump in, please do.
I can jump in. I mean, I talked about this a little bit in my talk, but it was motivated from a more real life example of I think what you monitor is very important. And even if you have the metric down, like, for example, precision or recall, the aggregation over how many days you monitor it is also very important. Like, for example, I was just monitoring a rolling recall score at my previous job, and that didn't capture a bug that was happening, or that didn't capture the data drift. Whereas if I'd been monitoring something like daily recall, I think that would have caught it much earlier. But that can explode really quickly, because then the question is, right, like, over what window do you monitor? How many windows do you monitor? What metrics do you monitor? If precision went up and recall went down, is that okay? If recall went up and precision went down. So I think a lot of that is very domain specific.
That makes a ton of sense. Max, were you trying to say something? Or Saeed,
no.
sorry.
I can. sorry. Okay, if I may basically
Yep.
to add to the discussion. So like other than areas that was basically suggested, one thing that is basically from the experience that we had, like model monitoring is a must. Not just because, and sometimes when you do it, you get very interesting outcome out of it. It's not just must to just make sure that the output of your model is in line with what you have built, right? Sometimes you do model monitoring and you get basically eye-opening result. You see that, oh, like when I built this model, like we had this actually happened to our team. Like when I built this model 4 years ago, basically I had some inputs that was coming as a feed, right? Like a data feed to my model, right? At the time, I was basically expecting different grades of importance for each of those input feeds, and that has changed within time without affecting my output. So think of it as basically like implications that you might have in basically in like saving the like in terms of like a dollar amount on the inputs to the model. If you are basically a middle user of another feed that inputs to your model, right? Something that you wouldn't realize that, for example, like in our case, it was like a pricing data that we were getting from another vendor, and that pricing the vendor B was basically providing like the output from vendor B has changed in a way that vendor A pricing data was much less relevant to the output of the model. And then that monitoring is basically a trigger to rethink about, okay, if I have to change the definition, if I have to basically change even my input data, the way that I'm basically having this model in production. So those kind of things is basically some aha moments that are happening when you just go back and dig into the model that is running.
That makes sense. So would it be accurate to say it is the dependencies between these models and assumptions that models make about their input and output, and when something upstream changes without the assumptions getting updated, then you're probably in for hell. Okay. Awesome. So that's a great start for us. I think we've already touched upon a few different facets, let's call it, of monitoring. There's the system monitoring, I heard explainability, there's Datadrift, there's debugging. So if folks could say like what monitoring is for them, like the number one thing that monitoring is for them, that would help. And I'll just call people out in an order so that we can save some time that way. So Max, if I can start with you.
Yeah, so for me, coming from more of an engineering background, more on the engineering side of things than the data science or machine learning per se, for me, monitoring it's more about the actual code base, or looking at the code as a product and really designing the code in such a way to facilitate the whole process.
Could you give an example of that so that people on the call understand it fully?
Yeah. So the way in which you modularize your code or the domain objects, or actually maybe a better example would be modularizing the tasks themselves. So if you know that you have a like training level and an inference level, and maybe like some pre-processing and so on, if your code base is well modularized and you see a particular error somewhere along the way, just by virtue of where it happened in your code, can potentially tell you already a lot about what might have gone wrong.
Got it. That makes a lot of sense. And hopefully people are following good software engineering practices in ML. Doesn't always happen. And maybe the topic for a whole different panel. But that's awesome. Let me go to Shreya next on what model monitoring means to you.
I think you were going to ask a question on this later, but I think it goes pretty hand in hand with debugging in the terms of like when debugging, you want to identify the bug. And monitoring provides a really great way to identify that. And the alternative is you wait for an end user to flag something wrong with your model, or you experience some loss in performance or money is going down the drain or something. So in that way, monitoring is just kind of that first step to replicating or identifying a bug.
Got it. So would you say for you, model monitoring is an early warning system, and it's really a means to an end, which is debugging, and I want to find out what's wrong with my model?
Yeah.
Got it. Follow up on that. Where does testing fit in?
I think this is hard because there's two things that, in my experience with ML systems, that we really tried to test, and one is data quality, and the other is whether the model is doing the task that we want it to do, and these can be two separate things. In my experience, the data testing, I've written a bunch of tests for data quality and whatnot, but it always just kind of goes to the trash because something new comes up that I never anticipated before. Whereas the model the behavior of the model stays the same if the distribution of the data stays the same. So one thing that I've also found very helpful is to do a lot of runtime checking, basically assertions in a lot of the transformations of data, as well as monitoring to make sure that things are as expected. Just because when the data changes, you don't really know what all of your errors are going to be ahead of time. So maybe that's asserting that your primary keys are like of a certain distribution, or I don't know. And this has helped me. Curious if it's helped other people, what other people do in this case.
Yeah, I mean, we use a lot of tests and stuff. So, sorry, I wasn't sure if you were asking us or saying more rhetorically.
All right, we will pick up on testing again in a little while. I heard data quality, and I really do have to get Sebastian's take on it. For those who haven't tried out DQ, Sebastian is the author of the data quality tool called DQ that works on Spark.
Yeah, my take is, of course, the data is the most important thing to focus on. So I think it's one of the new features of all these machine learning-based applications that they are so susceptible to changes in the data. And for me, it's also the thing that is most difficult to grasp for a lot of people, because when we educate data scientists, or when you take tutorials on Coursera or so, we always work with these nice, static, well-understood data sets in Jupyter notebooks. And then once you move to real production settings, you have to consume data from many sources. And I think in the majority of cases, this data is simply not under your control. So there's no guarantee that this data is well behaved, and there can be very simple and very subtle errors that can have devastating consequences. And there's also an interesting paper from the team that develops and runs the TensorFlow Extended platform at Google. And they also have some statistics that actually data changes in a source that are not communicated well are the major source of problems with many of the models.
That's awesome. Yeah. If you could drop in, a link for that paper either on Twitter or Slack, I think the community would be super interested in checking it out.
Yeah, I have a follow-up question for Sebastian on this thread. When we talked about the data quality monitoring, right, we were really looking at the baseline schema constraints that we take, and then we look at the statistics for each of those features, and then we do a comparison. And with DQ, which was built on Spark, I know like it does provide you out-of-the-box features, and I think SageMaker uses DQ for its model monitoring. Yep. So my question is, which you have a set of high importance features and low importance features. So when you look at the data drift, like, is this happening gradual, or is this happening abruptly? So you monitor it over a period of time. So how do you pick up what is the right amount of threshold, right? Like, for each and every one of those features, when you use a package like DQ, do you have control on that? Or is this everything like, I'll have it, my KL as less than 0.3, and then have my own monitoring piece, like which I write via a script and then monitor that. If it breaches this threshold, I'm having a threshold breach there. So how do I pick up for those features?
I think that's a really good question. It's actually a really, really tough question, because I think it depends on many different issues. So it depends on the data, but it might also depend on your model and how much weight your model assigns to certain features. So this is something where we do actual research. We don't have a good answer yet. Something that we've started to do is we have a library called Jenga that's available on GitHub, and that allows you to generate synthetic errors on your data, and then feed this erroneous data into your model and basically see how susceptible is your model to errors in certain features or in certain columns. And I think this can be a route to somehow assessing the robustness of your model. But I think in general it's a very difficult question that we haven't answered yet.
So extending on that, right? Is it fair enough to say that once I identify a drift in terms of the data quality, and then if I were to retrain this model, do I use the same set of model parameters? Because I'm more inclined to using the same set of model parameters, like which was deployed into production, use the same model, but use a different set of training set data, which is closely mimicking production. It's more like active learning kind of a mindset which I'm getting in, meaning get the data for which like my predictions in production are not correct, and then use them to feed it into your training set and then generate those insights. Will that help to alleviate some of the noise which I'm seeing in production? Or do I need to re-engineer my model one more time, start all the way from scratch when I address the drift? Which would be the better option?
I think so. I think that there can be many different sources of errors. Like if you have a gradual drift in your data, then if you regularly retrain your model on certain time windows, that should alleviate this. But okay, there can be simply systematic errors that are caused by, I don't know, somebody accidentally changing the schema or changing the unit of an attribute, and that's something that I think you will not be able to catch with retraining.
Okay, thanks.
Got it. So I heard system monitoring, I heard data drift monitoring, a bit of testing. Where does explainability fit in here, observability? And if folks who haven't yet weighed in can add to that, that would be awesome. Or anyone on the panel.
I can go in for explainability. A year back, I did give a podcast on explainability. The reason is with stringent GDPR regulations coming in, and it makes more sense for the financial sector to be compliant with explainability. So you can start off with bare minimum libraries with SHAP and Lime and H2O, and then start building your own explainability. Or with a simple LE5, you are trying to build some of the core drivers which are used for your model predictions. But when you want to take it up to the next level, do you use the explainability as a core feature for every model, or does explainability need to be baked in, before we even start working on a machine learning project? Because that to me is like building the right set of tools stack upfront before you figure out I forgot to factor in explainability because it's now costly for me to factor in there. So explainability in the financial sector is so important, and with various regulations, my thought process is: do I use some solutions like open source libraries which could explain to me, or will I be contented with that, or do I need to go in for a specialized vendor who's proficient in explainability? For example, the Fiddlers of the world, trying to get into that space. So do I go there? That's what explainability means to me.
Monitoring or explainability, if you had to pick one?
I would say it's a tough question. In the financial sector, yes, it is explainability. That's because you have a lot of regulations coming in, and explainability becomes a key factor. And for high volume transactions or high impactful transactions, explainability becomes a key factor. And monitoring is I think monitoring should be yet another driver with every machine learning project. Monitoring should be baked in for every machine learning project, no matter what. It's not a conversation that you need to have, do I need to have explainability or not? That you can have for explainability. But for model monitoring, you don't need to. You need to have model monitoring for every use case, at least in my opinion, because the ground truth labeling can drastically differ when you have the concept drift there. The labels that you labeled for your training set may not be the true labels anymore. They may not be relevant. So, yeah.
Got it. Anyone else want to weigh in on explainability or how you see that play with monitoring?
I can weigh in on an engineering perspective. I think Ganesh did a great job talking about like the top-down like legal or implications of something like GDPR requiring something like explainability. But I've also seen like for data scientists and engineering, people using explainability as a way to improve upon their model. So for example, let's say there's a business problem or a task, and I'm, as a data scientist, told like, hey, build a model to, I don't know, do churn prediction. And my model is like only getting me like 60% whatever recall on the first try. Like my first question is, okay, how do I improve on it? And data scientists naturally do this kitchen sink approach, right, of throwing all of the features at the model. You want to know what are the good features when you take everything in your feature store or feature table. What are the good features? How can I improve upon them? And in practice, a lot of these open source libraries, like I remember using SHAP all the time, for example, and these open source libraries are great in order to tell you like on a per example basis, or take like a handful of examples and compare them to another handful of examples and kind of see what is important or what are the important factors in making the prediction. But SHAP is slow, and a lot of these tools are just not easy to use at scale. So kind of, I don't think that there's a great explainable AI solution for the end goal of helping a data scientist iterate on a model pretty easily. And I also don't think, right, from the legal perspective, there's a great explainable AI tool of making sure that you could conform to whatever regulation. In the case of explainable AI versus monitoring, I feel like this is a really hard and weird question, because if you were to just treat like ML as software, right, how could you build software without logging things, which is essentially monitoring? How could you also build software if you didn't have stack traces, which is explainable or whatever explainable thing in a way, right? So I see them as like both super crucial and not one over the other, but yeah.
Awesome. That makes sense. Any other thoughts on explainability before we move to our next question on digging into the details of Datadrift? Alrighty, let's dig into Datadrift. I think that is probably the word that I've heard used so much and not understood. Everyone just says Datadrift and, oh, that solves my problems. When you think about monitoring, is it really the data drift that's the key issue? I heard some discussion about really picking the features that you want to monitor. That's way more important. Or setting the thresholds or setting the stats, because APM has a lot of threshold, like alert fatigue, like you're using monitoring as a means to an end. And so can we dig into drift more, and can people talk about the specific challenges that come up there?
Yeah, I can maybe. I'll just start off in the next 2 minutes. I'll just summarize why drift is so important. From my viewpoint. In my world, when I look at the predictions in my machine learning model, the kind of impact it has, right? Like, that is so important. That is the key driver for me. Meaning, when I'm looking at some of those features, and if I'm having a drift on the high importance features over a drift over the low importance features, and then if I'm going to use a time bound, as Shreya was talking about, and then use a time-based analysis, and then figure out, am I getting a gradual drift, and is my gradual drift more leaning towards the features which are of high importance, or are they increasing over a period of time gradually with my windows? And when I'm seeing those increases, am I completely discounting the fact, like, of those features which are of low importance? Because, like, am I biased, like, in giving too much attention only to the drift, like, which is happening on those features of high importance? Because if I do that, I'm consciously, making that kind of a biased decision. So how do I get past that? So that is one key aspect, like, for me, which I think, like, is a hard problem to solve, because it could be only a seasonal thing. It need not be a gradually increasing thing. It could be a one-off, temporary, not a permanent drift. And do I need to make corrective action every time when I see a drift? Do I need to have a human loop, human element involved whenever a drift happens? So all these monitoring tools, like, that you have with these platforms, you can have these monitoring, and then, like, you can have your model, like, retrain the moment when there is a drift there. But do we not? I feel that, like, you should still have a human element there, make those decisions, and then figure out, yes, this was a true drift because there were some significant changes in the external environment which the model would not be able to capture. So that's where that's where, like, my focus is on right now in terms of the drift.
Got it. Sebastian, I'm going to call you out on this one since you've been working on DQ. In your experience, like picking features, picking thresholds, what statistics to monitor, any rules of thumb that you can share, and any experiences there?
I don't think there's a good rule of thumb. So something that we've been doing is basically to use historical data and historical experience. So if you know that your system didn't explode in the past, then you can kind of take snapshots from the past, look at the changes between these, and maybe that's a first way to start. But I think there are also other perspectives on data drift. So one thing that I, for example, have seen sometimes is when you have different teams that work together on a model. It might be that the model is trained by one team, and then the model is given to another team that operationalizes it. And then maybe that team doesn't have like data science experts, and they are not so much aware of all these subtle problems. And then your model gets fed with data from a very different distribution. So it's not something that happens gradually. It's something that occurs maybe to organizational communication problems. That's something that we had often when we were like a consulting team that trained models for other parts of the business.
Got it.
It's basically like
back on that. Oh, sorry.
No, I just wanted to basically I think the challenge is to see the regime changes in the features of the model, and basically to quantitatively decide if those regime changes justify recalibration of the model. And that has been basically that has lots of dependencies, right? Like, for example, the technical debt that you have, like how difficult is the regime change, how difficult is the recalibration. If you think that regime change is something permanent or temporary, is it like something, for example, that we saw during the pandemic, like for our like. You see the changes in the input data, right? The question is, okay, should I basically should I change? Should I recalibrate my model because of this regime change or not? That's really the basically the hard part. That's just like. It is partly it's quantitative, but at the end it's just basically a combination of factors, right? That has to be considered.
That makes sense. Shreya, did you want to piggyback on the previous one?
No, I was just going to harp on this collaboration problem. Like, I think, yes, in practice, you see people, data scientists will build a model and then give it to somebody else to productionize, and maybe that team doesn't have a data scientist. But I don't think the problem is that they don't have it. Even if you put a data scientist on the engineering team, there's just still a huge amount of intuition developed from the person building the model and watching the monitoring or the alerts or the KS test statistics or whatever, KL divergence. There's so much intuition like that you build over months of monitoring a model, and that it's so hard to disseminate that. Like data science onboarding is a great example of this. If you onboard a data scientist on your team, they essentially shadow whoever the senior data scientist is to try to build that same level of intuition to know like what are the false positives in my model monitoring alerts. And I don't see a solution for this kind of knowledge sharing out there. Like you can have the best platform that will pick out 10 different features out of your 1,500 features and tell you the KS test statistics. But if you don't have the intuition to interpret them, and that's not like, oh, going to school and getting a stats degree, that's like you sitting there and working with the problem at hand, right? Which makes it incredibly hard to scale.
So that's why it's imperative to have the domain expert who built that model, very close to that model. And every time, like, when a drift happens, the person who used certain features for the model, and if he is gone, and if another data scientist is going to replace that position, it becomes extremely tricky. He may not feel that, like, the features, like, which he had used, might make sense anymore. So there's some kind of a bias again, like, when you're talking about model monitoring, bias is inherently introduced by way of these acts as well. So how do you figure it out? Yes, these tools can take you, can help you to walk through some parts of the dense area, but beyond that, it's the domain expertise, like, that would kick in with that. It cannot be a complete black box. You need to have a domain expertise within your team who's going to understand that end to end.
That makes sense. All right. Other thoughts on that? I think we're going to start making our way to more organizational questions as we get to the tail end of this panel. But other nuggets we want to share on Datadrift or libraries that you like using, or how did you build out your monitoring stack? There was a discussion around build in-house versus assemble open source components.
Assembling open source components is easy, right? You can build it straight away with SK and scikit-learn, and then figure out your entropy differences between your expected distribution and your actual distribution, and then pick out those wrong offenders. It doesn't take unique skill set like to do that. People who are expert in Python and with data science skills can start building on that. But the most interesting thing is, it's not that only one model that we're talking about here. So you need to have some kind of a unified plane wherein you can see all of those models which have been deployed into production, and then you should have those quality checks done periodically. Maybe platforms like Domino's might have those kind of data DMM, Domino's model monitoring features, which would help you to give you that kind of a visualization. And so the metrics which a data scientist develops, and how does the product manager views it? And how does the senior leadership views it, and then what kind of an impact it has on the society as well. It's like the small circle, and then the bigger circle and the bigger circle. So it's more like an nth order kind of a problem. And because with data scientists and machine learning engineers, we are pretty much into one bubble here. We are talking about our accuracy and our own metrics and our North Star metric that we pick for a machine learning problem. But a product manager who's using your product might see things completely differently. As long as it is working for him, he'll say oh, your model works great. But then if it does not, even though your model works great, and if it does not do so in the real world, how does the CTOs or the CEOs see this? So how do you communicate this the monitoring aspect across the chain? That to me is a big challenge in organizations.
Got it. I'll throw in a question that came up and is relevant here. There was a question about how we see model cards. I think that goes to communication, whether it's monitoring related or sharing knowledge related. And if anyone has an opinion there.
What does model cards
Model
mean?
cards DNA. Oh, this was a paper from Google. It's similar to, yeah, that one.
I have mixed feelings about this. I think that ML pipeline is not just one model. I think it's a series of retrained models. And in these series of retrained models where you have sometimes you might have different architectures, you might have different hyperparameters. In which case, does each model have its own model card? Or does the pipeline in itself, like a lot of this knowledge that's acquired over a long time working with the pipeline is specific to the pipeline and the data, not necessarily just a specific model architecture at the time. So maybe a pipeline card. I hesitate to give solutions in this way, but that's, I guess those are my thoughts on it.
Mm-hmm.
If I remember correctly, I think I read the paper a long time ago, then these model cards have to be created manually. So I think it's a good idea to have this information for models, but my worry would be that a lot of data scientists wouldn't have the time to create and maintain these reports manually. So it would be good if there would be some way to assist them with creating this information.
Got it. Awesome. Thank you. Go ahead.
Oh, yeah. Well, so admittedly, I have not read that paper, at least not recently, but we do try to account for that in our case to varying degrees of, I sort of don't like the thought process of like even a pipeline is like an end-to-end thing. I think that we do try to tie our models to various, data abstractions. In our case, we call them like workflows. And we have various forms of like data and metadata that are getting tied together such that, we also use tools like ML flow and things like that. But, I think that there are ways where you can be serializing so that it's just automatic. It's part of how either a developer or even a user interfaces with your data. So like I built like a little API recently, or we have like a command line interface where users can interface with the model based on various metrics about it. It's got like a unique ID. It's got, whatever else. So again, more on sort of the data and engineering side than on the model side per se. But that's, I think, a little bit more how I was thinking about it anyway.
Makes sense, like better tooling to auto-generate these cards and trying to bake it into your code itself so you don't need to do that extra effort.
Yeah, the user shouldn't even really have to think about that or be aware of like the deeper abstractions of it. It should just be sort of core to how the code base itself is designed.
Mm-hmm. That'd be awesome. I think all of us need that very well designed code base.
Whether we, fully succeed at it, but I think that's sort of what we aspire to.
That makes sense. Can people throw in more on building the monitoring framework? Ganesh mentioned that you can get fairly far with off-the-shelf things. In your experience, where do these current tools break down? Is it when you get to scale? Is it finding what you should monitor? What are the limits?
At least in my case, I tend to think of first, I'm more in the data engineer or MLE level than say like DevOps. So if we have tools that are going to deal with like the sort of orchestration level of things, I'm all for that. The less of that I have to do, the better. So we use Databricks for a lot of our tooling for our Spark clusters, for instance, or like Astronomer.io for Airflow for that deployment. Then if it's like visualizations, dashboards, I don't know, like Datadog or to some extent, even though Airflow is more on the scheduling side, you could think of it, the DAG itself as being a visualization. Those kinds of things, if it can be automated, I would prefer a tool to do it. If it's at the level of like the domain objects of the code and the code abstraction, that's where I'm going to go to, probably open source tooling first, and then probably wrap that around my own tooling or vice versa. But that's where I want like more flexibility, more control and ownership, at least personally.
Awesome.
to even kickstart your initial data quality monitoring efforts, right? I would still pick DQ as a starting point, because it's not. Yeah, I see thumbs up from Sebastian. Yeah, thank you, Sebastian. And yeah, I think that would be easier to start with, which means that you can even hand it over to the quality person who's doing the quality work for your machine learning models. Verifying the integrity of the data in the data pipelining and the ingestion stages. He could pretty much leverage DQ as a starting point, and then build custom-based solutions. And if you're lucky, and if your organization is investing in an analytics platform like Databricks, like what Max was talking about, Databricks also provides out of the box model monitoring features, and it's something which you got to pick and choose. Is there something? Do you invest in an analytics platform that has this as an additional feature, or are you better off with your existing technology stack, looking at the culture of your organization and the culture of the project that you're working on? Maybe you're better off in doing this monitoring piece all by yourself. So, but to begin with, yes, to understand the data quality, it is imperative to have some kind of a framework. DQ has, at least it sounded promising to me when I started looking at it. And yeah, that would be the starting point.
How about other folks, maybe Shreya or Sebastian, who have had to build these systems in maybe a smaller company, or in Sebastian's case, a very large company, but still, I don't think the tooling did not scale to their size?
For me, the biggest downside of many of the existing solutions is that they require a lot of effort to be integrated into the existing pipelines, like codes instrumentation or annotation. And in my experience, that was the biggest blocker to the adoption of these tools. Now, from an academic perspective, what one of my PhD students is doing at the moment is he's building a library to try to understand the semantics of common libraries used for machine learning preprocessing, like pandas and scikit-learn, and then exploring ways to basically automatically instrument the code with data quality checks or histograms to do distribution shifts and things like that. That's where I would like to see these things move to, simply increase the adoption.
Got it. Any other thoughts on that from the panel?
Yeah, I mean, I think, kind of along those lines, to some extent, I sort of feel like machine learning engineering and data engineering, these things are still sort of in a Wild West era where everyone's kind of designing their own sort of abstractions from the ground up. And so then you run into those issues, like you were saying, Sebastian, about how do you normalize that? And I don't know, it seems like if you could have that level of sort of a ubiquity or coherency in the way that to some extent maybe you see in web design, for instance, I don't know if it's at a tooling level or a language level or what, but that would, I think, simplify a lot of these things for sure. But
GraphQL-esque interface, I would love that for that sort of experience. That'd be amazing. And I don't think any of the tools out there, SageMaker, Databricks, all of them, they're great, but they're not that user friendly. So if we can get them to GraphQL, major win. So, okay, awesome. We're getting towards the very tail end. So let me throw out one question that is broader, and then we'll see if the audience has any others. What is MLOps to you? And I'm going to bump up one level from model monitoring, just your soundbite on what is MLOps.
Yeah, I feel like what I said for monitoring before was kind of the same as what I would say for MLOps, I guess, because for me, that's just more the level at which I'm focused. But yeah, really thinking of it at a engineering level, product level, both not just what tools am I using, but also how from end to end is my pipeline designed to facilitate monitoring.
Yeah, in my world, MLOps. Yeah, thanks, Max, for those thoughts. In my world, MLOps is just like fitness. It's a journey. You don't have a destination to reach, but you got to, it's like a moving buoy, like floating in an ocean. Every time you try to go close to it, it keeps moving. The target keeps moving. And you can never say that, like, I have taken care of all of my MLOps drivers. You keep working on. Now, like, you're talking about responsible AI, ethical AI, explainable AI. 3 years back, 4 years back, those were not even in the picture. And now people have started looking into it. So it's an evolving journey, and it continues to be, it will continue to be in that forum, like, for a long time. So good that, like, it doesn't have a destination, so you keep moving.
Nice. I'm going to call on Shreya next.
Yeah, I think very similar. Sorry, very similar to what Max was saying earlier, but just tooling for the software 2.0 paradigm. I don't like using software 2.0, but it's like the paradigm in which code produces code. And maybe not just limited to engineering tooling. Like, I can imagine that they're going to be like ML PMs and Asana for ML workflows, and just like all of this new ecosystem will pop up. But it's just a different way of writing code, and we need tools for that.
Makes sense. Sebastian or Saeed, do you want to weigh in on what MLOps means to you?
I think for me, it's first and foremost an interesting research area. And I think a lot of the problems that we see in practice come from a gap between managing the data and managing the models. And I hope that we can leverage a lot of the knowledge that the data management community produced over the years and somehow adapt these ideas to this new machine learning world.
Sebastian and I are fellow database nerds, and so we're very excited to think of all kinds of problems as database problems. I think, yeah, our community would be proud. Saeed, any last thoughts on that?
Nothing major to add. I think the panel covered it. It's just, for me, it's basically enablement to make data scientists' lives easier, like to basically bring software engineering best practices to the quants and data scientists' world in a way that they are basically they're ready for the basically the real world applications. That's basically the expectations that I have as data scientists on basically teams that are building MLOps. That's
awesome. Okay, I'm going to take one question from the audience, which I don't think has been covered, and then we'll wrap up. This one was for Shreya, and it said, are there any good benchmarks for look like in your opinion? And you have written a long response already, so if you want to just summarize that in a sentence or two.
Sure. I think you marked it as answered, and now I can't even see my own answer.
Oh, weird. Okay, I will. Okay, yeah.
No,
I probably know what you said, though.
I was just saying, I think, like, I don't know if one exists out there, so please correct me if I'm wrong or anything, but I think a great benchmark would include a task on some high variance data. So maybe like that's time series data, for example, and over a long period of time. So where you can actually optimize for consistently high performance, which would include like retraining a model or figuring out when to retrain and stuff like that. Yeah, at a high level, awesome. But I know that's super hard to implement practice.
Makes sense. Awesome. Well, thank you for the very wonderful panel. We are going to go over the recording again and produce a blog post that will hopefully summarize accurately all of our speakers' viewpoints here. Really appreciate all of you folks' time. I think this is going to be a very exciting space to watch. And as my only Verta advertisement at the end, which I must do since I run the company, we find the space very exciting and are building something which is shaping up to be pretty awesome. So if someone wants to give it a spin and tell us in what ways it needs to be improved, would love that. I threw in the link in the question and answer. So do check us out. It's on Slack, and I will also post it on Twitter. So with that, thank you very much to the panelists who have been awesome. Check out their talks as well. And we'll follow up with recordings of all of the sessions soon. So thanks all. Have a great day.
Thanks for having us.
Thank you.
Thanks for having us.
Thank you for having us. Thanks.
Bye.
Thank you all.
Bye.
Bye.